Okay, so members, now we are going to see how do we superimpose a histogram, a frequency polygon onto a histogram. Please don't forget to subscribe to the channel. We have seen how to do histogram. Now we are going to see how do we superimpose it with the frequency polygon. So now here the question is here. The table below shows shows weights of students. Construct the table and just find the median weight. Draw as a frequency polygon superimposed on a histogram. So now, this is how we calculate the weights, and here this one represents the frequency and this represents the weights in grouped form. So then my frequency is there. How do I get this x? This plus this then divided by 2, that's what we get. This plus this then by 2, that's what we get. Then this plus this, that's what we get, and so on. Divided by 2, this plus this divided by 2. Then I told you how do we get a class with it? You get this minus this, then plus 1, and so that our answer there is going to be a 10. Then how do we get a class boundaries? By getting first of all the adjustment factor. You get this minus this divided by 2, you get 0.5. Subtract it here. That's how we get the class boundaries. Then this 0.5, you add it here. That's what you get. You subtract here 0.5, you add it 0.5. All these classes here. Geometric frequency, you get the first geometric frequency is always the first here. Then you get this first, and then this, you get 9. Then this plus this, we get 19. Then this plus this, we get that. Then this plus this, we get 25. And so when you sum all this, you get this, and when you sum all these ones, that's what we get. Then they are asking us to get the median. This is the formula for calculating the median. We first need to know the positioning value of this median. We get this divided by 2. So our summation f is 25. Divided by 2, we get 12.5. The position. So this position, we look for it in the geometric frequency column. So here, you look where 12.5 is already. So this is in 3, this is 9, and this one we have already exceeded even 12. So it's in here. So now we are going to use all the row here. The lower class boundary is now for corresponding to this, which is this. Then this by 2 is there. Then geometric frequency before. Geometric frequency before is 9 over the frequency within. The frequency within here is 10. Then times I. Our I is the interval, class interval. And when you simplify, that's the answer you get. Now to construct a histogram superimposed with frequency polygon, you first construct a histogram. We said we use the weights, names we have here. If we have heights, their names we put on the horizontal. Then here we are putting frequency. Now from there, we do a histogram from 10, start from 10 to 20. Our frequency is 3. That's why from 10 to 20, the frequency is 3. Then from 20 to 30, the frequency is 6. That's why we see that our frequency is 6 there. Then from 30 to 45, the frequency is 10. That's why that is there, 10. Then from 45 to 50, 40.5 to 50.5, the frequency is 4. That's why from 40 to 50.5, the frequency is 4. Then like that also from 50.5 to 60.5, our frequency is 2. When you do it, we are doing all this on a graph paper. So now, after doing that now, to draw, now for a frequency polygon as we saw, for it is plotted with the frequency against midpoints. For it we plot it against midpoints. So midpoints, that's why for it I'm asking for the midpoint of this is this. The midpoint here goes with this. The midpoint here. This value here is going to be 35.5. The midpoint of this is 35.5. That's why I'm putting it there. Then the midpoint here is here. Then the midpoint here, which is 55.5, is there. And so now, for it, we're doing a frequency polygon using a ruler. So you get your ruler, you're doing this to this, then this, then this to this, then this to this. and there you have superimposed high frequency polygon on histogram. So that's how we handle that. I wish you well.